All right, good everyone. So you're welcome back. Uh, in this lecture, I'll talk about how to do integration in Python. So we'll start with uh, single integration, then we'll look at double integration and triple integration. So let's say we want to find the integral of a function f of x. The lower limit is a and the upper limit is b. So this is the integrand. F of x is the integrand, and this x is what we are integrating with respect to. Now, there are various numerical methods available to evaluate integration on the computer. One of them is the trapezoidal rule. The trapezoidal rule. Now, the simple trapezoidal rule is not useful, but I just give it here for reference sake. Okay, so the approximation is that if I want to integrate a function f of x with respect to x, that it can be approximated as the upper limit minus the lower limit divided by 2, then f of the upper limit plus f of the lower limit. Now, a better version of the trapezoidal rule is what we refer to as the composite trapezoidal rule. The composite trapezoidal rule, and it is given as integral f of x dx approximately h over 2 into bracket f of a plus f of b. A and b are the lower and the upper limit respectively, plus h, which is the spacing. So h is b minus a divided by n. So we can specify this n means the number of points that we need. Then plus h, so summation I equals 1 to n minus 1 f of x I. So this is the composite trapezoidal rule. So we implemented it too in Python, and we check the application to the integral of x squared from 0 to 2. So let's start with the trapezoidal rule. You know, the formula, the approximation is that it is b minus a over 2, then into bracket f of a plus f of b. Let me use a square bracket here. Yeah. Okay, so I think it's better. So f of a plus f of b, then multiply by b minus a over 2. So we start with b minus a over 2, which is the factor, then multiply by f of a plus f of b. So it's as simple as that. You know, it's similar to the way we implemented the numerical methods for differentiation in our last lecture. Now, the composite trapezoidal method is a better formula. So this one is not often used. This formula is not often used we don't use it in any scientific computation. We use this composite trapezoidal rule. Okay, now how do we implement that? So we have h over 2 f of a plus f of b. So h is b minus a over n as is written here. Let me show you. I think I have to reduce the so h is b minus a over n, h is b minus a over n. So the function, you know, for the trapezoidal, the function I want to, it depends on the function I want to integrate, the lower limit and the what? Upper limit. Okay, the function I want to integrate, the lower limit and the upper limit. Now, but for the composite trapezoidal method, it depends on the function I want to integrate, the lower limit, the upper limit, and the number of data points that I want to create. And we'll see the implication of the values of n. We'll see that shortly. So h is b minus a over n. xi means xi, they say, is a plus ih, but we can create it in Python by using the a range. Okay, we start from the starting value, which is a, the end value, which is b, and the spacing which is h. Okay, which is h. Then y, so I termed y1 as h over 2. Sorry, I have to reduce the so I termed y1 as h over 2. Okay, I want you to see the way I'm coding it. So then f of xi, so of 0. Xi of 0 means the first value of xi in this place. The first value of xi. You know, we have talked about this before in Python. So let me go to Python. So if I have this, I will create x, let's say from numpy import maybe linspace, and we say x equals linspace 0, 10, 100. So the first value of x is 0. So if we want to access that, we say x of 0, we got 0. Then if we want to access the second one, which is x of 1, so x of 1 is going to be 0.101 and so on. And if we want to access the last number, we say x of -1, which is 10 in this case. Okay, so take note of that. We have done this in, I think, maybe the second class, I think so, or thereabouts. So xi of 0 is the first number here, which is a. Then xi of -1, it means it's the last one, which is b. Okay, so f of a plus f of b, then plus h plus, okay, so this is h, which is the second part, h, then sum f of xi, sum f of xi. Okay, so we just sum, we'll create f, then we'll put in all the xi. Okay, then we sum. So this is a function. Sum is a built-in function in Python. Then we return y1 plus y2. This is y1 and this is y2. So y1 plus y2. So the integrand, or we want to use the two methods to evaluate the integral of x squared from 0 to 2. Integrand. So our integrand is x raised to power 2. The lower limit a is 0. The upper limit is what? Is 2. So let's start from n equals 10. Now this integration, the exact value, if you have integral x squared from 0 to 2, right? Yes, dx. So the integration is that it should be x cubed over what? Over 3, then 0 to 2. So you put 2 raised to power 3 over 3 minus 0 raised to power 3 over 3. So 2 raised to power 3 is 8, so that will be 8 over 3. 0 raised to power 3 is 0. So it means the answer is what? The answer is 8 divided by 3. So that is the exact answer. So the exact answer is 8 divided by 3. So when we use trapezoidal rule, the integrand, the lower limit and the upper limit, when we use the composite, because this composite named the function composite underscore trapezoidal. So composite underscore trapezoidal, then the lower limit a, upper limit b, and the number of points. Then you can print the result. So if you print the result, you have trapezoidal rule 4.0, composite trapezoidal rule 2.6, the exact value 2.66666, and so on. Error in trapezoidal 1.3, error in composite minus 0.06. But this composite, we can increase the accuracy by increasing this n. If we increase this n to 100, instead of, look at the error before we increased it, 0.062. Now after increasing it, the error is now 0.000662. Okay, and you can increase it further to increase the accuracy. Okay, it's now very, very small. But this trapezoidal rule is still not accurate enough. There is a better method, which is the Simpson's rule. So the Simpson's rule, the simplest one, is given as p minus a over 6 f of a plus 4f a plus b over 2 plus f of b. And again, we can easily implement this in Python. We just say fact p minus a over 6, which is this p minus a over 6, then multiply by f of a plus 4 times f of a plus b over 2, then plus f of b. Very simple. The integrand again is x squared. Lower limit is 0, upper limit is 2, exact is 8 over 3. Now if we use Simpson's rule, look at it. The error is 0. The error is 0. So the Simpson's rule, where in this usually it's not usually 0, but at least in this case it gives the exact results. So the Simpson's rule is far better than using the trapezoidal rule. It's better than using the trapezoidal rule. But we will see shortly that the Simpson rule does not always give exact results. We will see that shortly. So we have learned how to do numerical integration using trapezoidal rule and a better method, which is Simpson's rule. Now in Python has a function called quad. okay, using the quadrature method. So if you want to use the function, you say from scipy.integrate import QUAD quad. Now, how do you use the quad? Now again, this is the integrand that I want to integrate. So you just say the quad, the function wants to integrate, the lower limit and the upper limit. If you print this, you get almost exact result. The error is very, very minute. 4.4 times 10 to the minus 16. So that's like 0. Okay. Now, so let's take another example. So in this example, we have work done, which is defined as the integral of nRT over V. Okay. From the limit of integration is from V1 to V2. So n, where in this question, n is given as 1 kilomole, the temperature is 300 Kelvin, the constant R is 8.314 kilojoule per kilomole Kelvin, and the V1 is 1 meter cubed, V2 is 5 meter cubed. So we are asked to evaluate this work done. So we are given some parameters. So we are given n, t, r, v1, v2. So n is 1, t is 300, r is 8.314, v1 is 1, v2 is 5. Now func, which is our integrand, the function I want to integrate, it is nRT over v, nRT over v. Our variable here is v. Okay, is v. V varies from v1 to v2. So let's start from n equals 10. That is for the composite trapezoidal rule. Now for the Simpson rule, it does not require any n. I mean the Simpson rule we are using here. The same thing with the chord function and the regular trapezoidal, simple trapezoidal rule. So if you use all those four methods, trapezoidal rule, composite trapezoidal rule, Simpson's rule, and the chord, the Python chord, the exact answer is 4.014260041 times 10 to the power 3. So that's about 4014.260041. So that's the exact value. So if you run this, the exact value is 4014, trapezoidal 5986, composite 5052, Simpson 4212. Simpson, but look at the error, 198. Okay, it's close. It's closer compared to trapezoidal, but it's still far off. And chord 4014. Okay, so chord gives the best results in this case. So usually if you're using Python to do integration, so we recommend that you use the quadrature method. Of course, you can increase the accuracy of the composite trapezoidal rule. The error here is 1037. Let's change this to 100 and check the error. It has reduced to 100. Okay, from 1000 reduced to 100, so it's good. But I will recommend that you use the chord function if you are writing a code for your research. Okay, that's about a single integration. So these are some simple exercises. Okay, so next is double integrals. How do you deal with double integration in Python? So to do double integration in Python, we use the function dbl quad. dbl quad, that is dblquad. That is the function that we use for double integration in Python. For example, let's say we want to evaluate this integral y sine x plus x cos y, the y dx, from y is from 0 to pi, while x is from pi to 2 pi. So what we do is we import the double quad also from the scipy.integrate. You know, we imported quad from scipy.integrate. If you check up here, from scipy.integrate import quad. So again, we import double quad, that is dblquad, also from the scipy.integrate. Then of course we import this geometric functions that we need, sine, cos, then the constant pi. So the function that we want to integrate, which is the integrand y times sine x plus x times cos y. Now double quad, not just a double quad, the function that I want to integrate, the lower limit for the x, the upper limit for x, lower limit for y, upper limit for y. And look at this integrand, it must be y comma x, not x comma y. So please, you must take note of this. If you use x comma y, so you may get an error. So y comma x. Then the limit of integration, the first one is for the x, which is pi to 2 pi, and the second one is for the y, which is 0 to pi. Okay, so please take note of that. So if you print that, you have minus 9.8 and the error is minus 13, 10 to the power minus 13. Now the double quad and the quad, they return both the answer and the error. So that's why here I have answer ans dot comma err, because it's like a tuple. Okay, if you let me mute this. If you just print, if you just say Control C, let's say we have just y, maybe y out equals that, and you print y out. If you print y out, it will print both the results and the error. Okay, so it's a tuple. It will return a tuple. So the answer and the error. Okay, so but I think I prefer to separate the errors and the answers. So answer, let me know my answer, then the error. So you have that. Okay, another example. We want to integrate x y squared dy dx. Y is from 0 to 1 and x is from 0 to 2. So again, f y comma x, take note. Then x times y squared, double quad, the function I want to integrate, which is f here. The lower limit 0 for x is 0, the upper limit for x is 2, lower limit for y is 0, upper limit for y is 1. If you want to know which lower limit covers for which one, so this is dy is closer to the function, so this integral 0 to 1 is for dy, and the x is farther away, so this integral is farther away, so this dx is for 0 to 2. So the limit for integration for x is 0 to 2, and for y is what? 0 to 1. So this is classwork. So these are some exercises. Okay, next, triple integration. How do we do triple integration in Python? We use the function tpl quad. For single integration, we use quad from scipy.integrate import quad. For double integration, we use from scipy.integrate import double quad, which is dbl quad. Then for triple integration, we use from scipy.integrate import triple quad, which is tpl quad. Okay, tpl for triple, so quad. So for this simple integral, we have x, y, z. Again, we create a function for that. Here I'm using a lambda function. I've taught you, I think it's maybe the second or third lecture, I talked about the lambda function. We can use lambda function, there's no problem. So lambda function again is to start from z. You know, for the double integration, I said it must start from, it must be y comma x. Okay, now for the triple, it will be z comma y comma x. So return x times y times z. Then use the triple quad. The function I want to integrate, it is func in this place. The lower limit for x is 0 to 1. Okay, so the function to integrate is lambda z comma y comma x, x times y times z. So you call the triple quad function from scipy.integrate, then func, which is the function that we've created, which is the integrand. So this func is the integrand x, y, z. Then the lower limit for x, again you start from x, which is 1, 2. The lower limit for y, 2, 3, and the lower limit for z, 0, 1. Then you print your result. So this is the answer and the error. Now lastly, it's important I give this type of example because some of the questions that you encounter in test and exam. So you have integral x, y, z, dz, dy, dx. The limit of z is 0 to 1 minus x minus 2y. The limit for y is 0 to 1 minus 2x, and the limit for the limit for y is 0 to 1 minus 2x, and the limit for x is 0 to 1. Okay, so how do we solve this? So again, we create a function which is z comma y comma x, then return x times y times z. Okay, but in this case, if you see the previous question, we input the lower limit and upper limit. But in this case, if you look at the upper limit here, you have 1 minus 2x. Here you have 1 minus x minus 2y. So it's not just number, it's a variable. These are variables, x and y. So what we do is the func, the lower limit for x is, there's no problem, it is 0, 1, 0, 1. But the lower limit for y is from 0 to 1 minus 2x. So we can now create another lambda function in it. So that's how you deal with that. You create a lambda function for the lower limit, you name it 0, and it depends on x, because this is for y. So y would depend on x, z would depend on x and y. So this z would depend on x and y would depend on only x, and x is just a number. Okay, you can see z here, it depends on x and y. Okay, so lambda x, which is for y, so y depends only on x, so it's from 0 up to 1 minus 2 times x, 0 up to 1 minus 2 times x. Then for z, the lower limit is lambda x comma y, because z depends on x and y. So the lower limit is 0, then lambda x comma y, the upper limit is 1 minus x minus 2 times y. Then you print your results. Okay, so it's as simple as I just need to go through it and be very, very careful. Okay, so this some exercises that you can try. So please, I think you submit these exercises. Please submit those exercises. You can send them to my email. All right, so we'll stop here for today. So I think next class we'll talk about interpolation, curve fitting. Interpolation and curve fitting. So I think that's the next topic. All right, so see you later.